Okay, so section 5.8 again deals with integration using tables and computer algebra systems. Now, in our upper level math classes, the 200 level math classes, sometimes we will use MATLAB. That's a computer programming language to compute integrals. But at this stage here, you are still learning the process of integration, and sometimes using a computer is not always the best way to find an integral. So sometimes using the tables is actually better, because a computer, like MATLAB, if you integrate an integral using a computer, sometimes you can get a very complicated expression, believe me. So what this is, these reference pages, this table of integrals, there are 6 pages or 5 pages of integrals, 120 formulas. And these integral formulas have been developed over, the last several hundred years. As mathematicians found integrals, they would basically contribute their discovery, and the discoveries would be put into a table of integrals. It's like a dictionary. It's like a dictionary with a bunch of integral formulas in it. So mathematicians, when they had to find integrals, they often would refer to this table to help them get an answer. Now, some of these integrals are ones like, the way they came up with these integrals is basically through techniques of integration, like you learned. So for sessions, of course, 5.5, 5.6, and 5.7, you're expected to use the techniques of integration and work through the problems and do the integration, work it out. But for section 5.8, these problems, you are able to use the table of integrals. So what I'd like to do is do a few examples here involving the table of integrals. And you should have this table of integrals downloaded. Okay, remember, it's in Blackboard, course content. Go to section 5.8, and there's a link for table of integrals. Okay, so let me, I downloaded the table, and I was able to view the pages, all 5 pages. How many of you downloaded the table of integrals and are able to see all 5 pages? Okay, Michael, you see it? Michael, do you see all the pages? Adriana sees all the pages. Okay, so people are seeing all the pages, so there must be something, something, maybe you have to, I'm not sure why, but you ought to be able to see all the pages. It takes time to load. Snega says it takes time to load. Okay, all right. All right, let's look at, and I'm not sure why, I'm also not sure why that funny thing, wait, Tina says, once I downloaded it, all pages show. Yeah, so you have to download it, right? You have to go into, hold on here. Let me go back in here, one moment. Okay, so once you're in the course content, click on the table of integrals in section 5, sorry, it's in section 5.8. Click on the link for table of integrals, and then go here for download. And you have to download it to your computer. And then when you download it and click on it, click on the file, you ought to be able to see all 5 pages. Okay, one moment here. Okay, all right, excellent, excellent. It is in your ebook also, but it's easier to just give you the thing. Now we'll have to talk about that, okay? We'll have to talk about that. I'm not sure why that's occurring for you, but let's just give it a little time. Let's see what happens. Before you leave class today, we'll figure out that. So okay, let's go ahead and work on a problem here. So section 5.8. Here's the first example. Let me give you a chance to copy it down. Okay, so we want to use the table of integrals to help us evaluate this integral here. So what I need you to do is I need you to look through your table of integrals and try to find what formula most resembles this integrand here. There's a square root involved, so the formula, whatever formula you pick, is going to involve a square root. Let's see what possible formulas you think are good candidates. And when you think you have a good candidate, I'll write down, okay, so we have, Rodrigo thinks number 18. 18th formula, okay. Okay, Snega thinks formula 28. Okay. Rodrigo thinks 28. Okay, so I'll take out 18 and put 28. Doesn't have to be on the first page, 36. Michael says 36. Jonathan says 45. Okay. All right. Well, let's stick with those right now. 28, 36, and 45. let me go ahead and bring up that that table here. Okay. Now hold on. What I thought I wrote it down. What were the candidates? Formula 28. I think it was formulas 28, 36, and 45. Right? Okay. Thank you, Snega. Thank you, Tina. Let's look at 28 here. You blow that up a little bit. Okay. And remember, that our integral, we had the integral of 1 over x squared times the square root of 4x squared minus 7. I'm not worried about the limits right now. Oh, I see an issue with this formula 28. I see an issue. It's pretty close, but where's the problem lie? Why can't it be formula 28? Well, we use squared, so you have a variable squared here, and we have a variable squared here. That's okay, actually. But there's a big difference. Ah, Michael, that's right. We have a plus in the square root here, and our problem has a minus in the square root. So it can't be formula 28. It cannot be formula 28. Good try. Good try. All right. Is everybody okay with that before we move to formula 36? All right, Snega, very good. All right, formula 36. Again, let me write down the integral. This is where it takes a little longer with the remote teaching, but you know we're gonna do it right. It's 4x squared minus 7. Well, with formula 36, there is a minus there, but there's still a problem. There's still a problem. In formula 36 under the square root, you have a squared minus u squared. That's right, Snega. A and u are in a different place. So a is a constant. A squared, this a squared here, okay, this a squared is a number. It's some number. So you have a number minus a variable squared. But in our formula, or in our integral, we have a variable squared. I mean, 4x squared we can write as 2x quantity squared, right? So you have a variable or a function squared minus a constant, but you don't have a constant minus a function squared. So that's going to rule out formula 36. You need to have the u squared minus a squared under there. Okay. So we have like a variable squared minus a constant squared under the square root. 7 can be thought of as root 7 squared. But it's not a perfect match. All right, is that good before we move on to formula 45? All right, Tina, very good. All right, Snega. All right, so on to formula 45. Formula 45, hold on, I went too far. Here's formula 45. That's going to work. That's going to work. Okay, but we're going to have to make a little adjustment to our integral before we can use formula 45. We're going to have to make a little adjustment. So let's get back to the problem. No, I don't want that. Hold on. Oh, okay. Hold on. All right. Now wait, what's this? Yeah, stop sharing that. Give me my table, please. Okay, I'm just waiting. Takes time for things to load. I think that's part of the issues that some of you that couldn't see those pages right away. It's a loading issue. Okay, so we agree formula 45. But, and I'm going to let you copy this, but we're going to have to modify the integral first. We're going to have to let u equal 2x. Because in formula 45 square root, you have a u squared minus an a squared. 4x squared, you don't want 4x squared, you want just a variable squared. Well, 4x squared is the same as 2 times x quantity, that's a 2 times x quantity squared. Hence, you're going to let u equal, you're going to have to let u equal 2x. You're going to have to make a substitution first. The 7 can be thought of as, that's where a squared is. So 7 is going to be the same as root 7 squared. That's how you have to think of it. Okay. All right, so let me let you copy down to here. All right. Okay, all right. So are there any questions? All right, so what's making this u equals 2x? That's going to help us because if u equals 2x, then it turns out dx is 1/2 du. So what you're going to do is, for a lot of these problems, not all of them, but for a lot of these problems from section 5.8, you first have to make an appropriate substitution. And you have to use the table of integrals to do these problems. Okay, that's how you need to do them. Okay, like if you see these kind of problems, section 5.8 problems on your exam, and I'm going to talk about that next week. You know, on Tuesday, I'm going to talk a little bit about how the exam's structured. But if you see these like a section 5.8 problem, use table of integrals, then you must use the table of integrals. Okay, that's how you have to do it to get credit for the problem. Okay. All right. All right. So by letting u equals 2x, I replace the 4x squared, square root of 4x squared minus 7 by the square root of u squared minus 7. Okay, that makes sense. The x squared, well, I have to substitute something in for x. If u equals 2x, then x will equal 1/2 u. And so I replace x with u over 2. And that gets me the u over 2 squared. Now I notice here I left out a dx, didn't I? I left out my dx. The dx has to be replaced as well, but dx is 1/2 du. And then, of course, both the x limits, 3 and 2, get replaced by 6 and 4. Because u is equal to 2 times x. Yes, Sergio. Sergio is asking about the u over 2 part. So the x squared here, we're converting this integral through the substitution. We're converting the integral to an integral with respect to x. We're converting that to an integral with respect to u. So the x squared has to be written in terms of u. Well, what is x equal to? If u is equal to 2 times x, then if you divide both sides of that equation by 2, you'll get that x equals u over 2. And that's why I substituted for x a u over 2 here. Okay, is that? All right, are there any, okay, Sergio's good. Are there any questions on that? All right, well, now, is this formula, is this rewritten integral here, are we ready to apply the formula just yet? Or should we do a little simplification? I think we have to do a little simplification first, right? That's right, Tina. So let me go to the next page. That's right, Michael. U over 2 can be simplified. So let me go to the next page here, if we're good. Tina's right. Get the 1/2 out of the integral. This 1/2 here. So on the next page, I've rewritten the integral. Well, no, I just wrote the integral down again. And u over 2 squared, u over 2 quantity squared is the same as 1/4 times u squared. The 1/2 got brought out in front of the integral. And this 1/4 here is the same as 4. And so 4 can be brought out in front of the integral. 1 divided by 1/4 is a 4.
Wait, how did we get the 1/4?
Okay, good question, Tyreek. One moment here. U over 2 squared is u over 2 times u over 2. That's just u squared over 4. That's u squared over 4. All right. So and so that's 1/4, of course. That's just then 1/4 u squared. Comfortable, Tyreek?
Yes, thank you.
All right, you're welcome. All right, well now, so we get here. 1/2 times 1/4 is 2. But now I'm ready to apply the formula. This integral here, this integral is in the right form to directly apply formula 45, and that's what I have here, formula 45. So the antiderivative of 1 over u squared times the square root of u squared minus 7 by formula 45, and since I'm applying formula 45, I write it down right here. That's going to equal then the square root of u squared minus 7 over 7u, and I'm evaluating that at 6 and 4. So whenever you apply a formula, you identify what the formula is. That's part of the work, and you put it over the equal sign to say, hey, I'm using this formula. And then the rest is just easy. Are there any questions? Okay. Okay. All right, and then the final answer then is going to be, we can simplify a little bit, and then we'll get our final answer. All right, are there any questions? Sure. Tariq, let me go back to the previous page, and we'll come back. Yes,
Professor,
yes, yes.
I had a question on this. So I understand for the formula, we would like for the bottom of the form. So I know the formula is du divided by u squared square root of u.
Oh, you mean going back like
Yeah.
here?
Yeah. How come we didn't like need the? How come we didn't need to square root the 7 when we converted? Like,
Well, so 7, that 7 there that's my a squared. That's the constant a squared.
okay.
That's what we're doing there. All right.
Okay.
Good question. Good question. All right. Let me go back to the run here. All right. So, and of course, class, sometimes, well, yeah. Are we ready to move to the next question? We should do one more.
Quick question.
Yes, Sergio.
So you wrote at the top, you wrote square root of 29 over 21, and at the bottom says.
Oh,
Yeah.
yeah, 2/22, 2 over 42 is just 1 over the square root of 21, simplifying. Oh, I have a typo.
Yeah,
Good catch.
that's what I was trying to say. Yeah.
Thank you, not now.
Yeah.
Okay. All right, so this is going to be in the recording. This is going to be in the recording. Do not worry about that, Sergio. It's going to be in the recording. Okay, good catch. All right, let's move on here. Let's get to the next example. Sergio, what I can do is like we'll have a little time for classwork. I can then go back if you want to, but generally, you don't want to take photos. You want to write down notes, right? That's the best way to do it. But I'll accommodate you there. But let's do this next example, and then you remind me after class, and I can make it smaller the size so you can snap photos of each page. That's okay. Okay. All right. Very good. So here's another one. Here's another one. And we have to figure out, in this example, which of the formulas is going to be the best one to use. So after you copy this example, look through the integral tables and let's see if you can find what the closest formula is going to be. And remember, arctangent is the same in terms of notation. That's the same as this notation, right? So, all right, take a moment and then let's see if anybody can offer some formula. Okay, Rodrigo says he thinks it's formula 92. That was fast. I didn't think, you know. Who agrees with Rodrigo? Who would like bet $100 on it? That is Formula 92. Tina thinks it might be 92 as well. Well, you know, let me see here. Jonathan thinks maybe 95, Snega 93. So you're all in the ballpark. You're all in the ballpark. One of those is going to be right. What do we have to do? You know, 92, 93, 95, those formulas, one of them is going to be right. What do we have to do first, though? To identify the right formula, in this case, what do we have to do first in the problem? What do we have to make? We have to make a well, what do we do in the last problem to help us? What do we need to do? We needed to make a substitution. That's right, Snega. That's right. That's right, Tina. So we're going to do that here. Now, you're right. You're right. Formula 92 is actually going to most closely resemble the integral. The reason is because you have a variable thing here. I'm kind of talking, you know, sort of like a kid, but sometimes it's helpful to think like a kid. I have the arctangent of a variable, you know, x is a variable, so e to the 15x is a variable. Well, that makes sense that I would write then e to the 15x is u. And then I have another variable here. So 92 is going to be the one to use. But it still isn't quite a match. But let's just let u equal e to the 15x power and see what happens. Okay, so I'm going to let u equals e to the 15x power, and I get du then by the chain rule. But this problem involves a little trick. You see, the e to the 30x, I can write that as e to the 15x times e to the 15x power. Okay? And so my integral I then can be expressed, I'll put this in red. This is really where the integral I can be expressed as you see it here in the red. Okay, I'm going to give you a moment to think about that. Okay. Are there any questions on what you're seeing here on the page? You have to let me know if you're uncomfortable.
Yeah, I'm confused how you got the e to the 15x. Wait, oh, never mind. I think I got it.
All right. The reason I knew to write e to the 30x is e to the 15x times e to the 15x is because, well, I know u is equal to e to the 15x. So, but the beauty is, you see, the e to the 15x, there's a product of two of them, and one of them gets absorbed so that you get a du out of it. All right, and so and incidentally, in the final answer here, e to the 15x quantity squared will equal e to the 30x. Okay, we can re-express e to the 15x quantity squared as e to the 30x. Are there any other good questions? Okay. All right, so then I'll move to the next page then. All right, this then is going to be the answer. And so your integral is this. So, you know, this table you have has 120 formulas, but you know, there are tables of integrals and tables of integrals where there are a lot more formulas than that. I mean, there are a lot more formulas available for integrals, and again, you know, it's just a benefit to society when a mathematician finds an integral, a general form of an integral, and then shares it with the rest of society. It's helpful to everybody. All right, so what I want to do, let me stop the recording.